Good morning to all. My name is Nurfatihah Rahim. Today I will present about energy measurement and potential energy conservation measure in 5 healthcare building in Malaysia. So my presentation content include of introduction, problem statement, objective, generation of energy, energy act and policy, general operation of healthcare building, research methodology, data collection, result and discussion, and last but not least is conclusion. So for the introduction of this study, the trend of world energy consumption indicate about 73% is come from non-renewable energy source, and the depletion of the non-renewable energy sources quite worried the world to sustain the energy demand. In Malaysia, about 80% of generation of electricity come from natural gas and coal. The increasing number of buildings in Malaysia will have an excessive impact on national development, and it may demand a high energy to supply. The increasing development of building and construction also worried the nation as it will reflect on emission of carbon dioxide. Healthcare building is one of the example of commercial building and known as a complex and high energy demand building. Healthcare building use a lot of energy during 24 hours of operation. They need energy for their lighting, air conditioning system, for biomedical equipment, office equipment, and others. So what's the problem we having right now? Firstly, a healthcare building is a complicated and energy intensive structure. It consumes a lot of energy and it will cost a lot to the building owner and emit higher carbon emission if not been monitored. According to US Energy Information Administration 2020, the highest consumption by sector is industrial, commercial, transport, and residential. So healthcare building is categorized under commercial. Secondly, is currently no specific standard used to measure energy consumption and efficiency that focusing only to the healthcare building. Currently, we are using BEI, Building Energy Index, that used for all type of building. It more focusing for office type that have a normal operation. So the current BEI might misinterpret the energy usage in healthcare building. Thirdly, the effort to minimize energy usage in healthcare building is not emphasized enough. Next is the objective of the study. First is to identify building characteristic, energy consumption to operate the healthcare building. Secondly is to propose potential energy conservation measure, ECM, and analyze in terms of economic benefit. And lastly is to develop Healthcare Building Energy Index, HBAI, to measure energy usage of healthcare building. Next is the generation of energy. The generation of energy can be divided into two, which is RE energy, renewable energy, and non-RE energy, non-renewable energy. So for RE, we have solar, biomass, wind, geothermal, and hydropower. For non-RE, we have fossil, coal, nuclear, and natural gas. In Malaysia, 40% of the country earn from the oil and gas. And we can say in Malaysia, about 80% of electricity is generated by natural gas and coal, which is cannot renewable anymore. Next, we go for Energy Act and Policy. In Malaysia, we have energy commissioning, also known as a Suruhanjaya Tenaga. So what energy commissioning do? They regulate and enforce energy supply operation and legislation in Malaysia under the Energy Commissioning Act 2001. The function of energy commissioning including providing advice to the minister in all matters concerning of national policy objective for energy supply and activities, to control all aspects of electricity supply sector and to safeguard everyone from the danger of the electricity. Next is increasing efficiency and economy and safety in generation, production, transmission, distribution, supply, and the use of electricity. It also encouraged the use of renewable energy while conserving non-renewable energy. The example of energy and policy that been enacted to promote energy efficiency in Malaysia, such as Electricity Supply Act, Climate Change Policy, Energy Commissioning Act 2001, National Green Technology Policy 2009, National Green Efficiency Action Plan 2016, National Green Technology Master Plan. Beside that, we also have the energy policy that been implemented in Malaysia. For example, we have Malaysian Standard 1525 is a code of practice for renewable energy and energy efficiency in residential building. Next, we have ISO 5001 International Energy Management that give the continuous improvement in term of energy performance through a systematic strategy according guidebook. National Building Intensity Labeling, also a standard to measure effectiveness of building in industrial and commercial sector in MASTEC. Right now, for government building, they are using this standard to measure their energy efficiency in their building. Next, we also have the Asian Energy Management Scheme, AMAS, is one of the initiative from regional Asian effort that create and endorsed by the Asian highest energy authorities and organization, including 10 Asian countries. EMGS or Energy Management Gold Standard is the certification system based on energy management excellence that offered by the AMAS. Next, we also have the Green Building Index, GBI. Is one of the green grading system to raise awareness about the green building in Malaysia. For example, for the project that related to energy efficiency, we have Low Energy Office is now for Office for Ministry of Energy, Water Technology is one of the national demonstration project to increase the building energy efficiency and reach rating BEI about 100 kilowatt hour per year per meter square. Next, we go for general operation of healthcare building. So the healthcare building is highly energy intensive and have long operation hour to maintain their demanding operation. Normally, hospital use energy to sustain their operation about 2.5 times more than the commercial building, according to American Society Heating, Refrigerating and Air Conditioning Engineer, or known as ASHRAE. Why it use a lot of energy more than commercial building? Because it has its own set of design, standard and equipment, occupancy rate and their operational schedule. Despite an increasing of energy demand from the healthcare building, the awareness to manage is still low. There are the major barrier. Firstly, low awareness among you owner and facility manager on energy efficiency opportunity and approach to harness the same. Secondly is limited availability in-house expertise to identify the energy saving project and their implementation. Lastly, lack in-house energy management organization structure. Normally, only one person will be responsible to achieve the energy efficiency standard. Next, according to Ministry of Health in Malaysia, there are 5 types of healthcare building. Firstly, we have general hospital, district hospital, clinic and teaching hospital, specialist hospital, and also the laboratories. Next is the research methodology. So the method used during to gather the information during this study, we have desktop audit, and then we have meeting with the building representative and on-site energy audit. The equipment that widely used during this research is lux meter and also the clam meter. So the step during to gather the information, first step is meeting with the building representative. Second step is desktop audit. Third step is on-site of energy audit, which is we are collecting of data of cooling and lighting equipment. And lastly is the data analysis. So for the data collection, for this study, we have 5 different locations which represent different type of building. For example, for building A, located in Batu Pahat, Johor, is represent for University Head Clinic or clinic. For building B, located in Putrajaya, is representing the major hospital. For building C, located in Selangor, is representing district hospital. For building D, located in Johor Bahru, Johor, representing state mental hospital or specialist hospital. And for building E, located in Kuala Lumpur, is the laboratory. So each of these building have a different net floor area and also number of staff. Meanwhile, for electrical tariff, they are share the same electrical tariff for building A, B, D, and E. Meanwhile, for building C are using tariff B, while the rest are using tariff C1. For yearly energy consumption for building A, using about 1 million kilowatt hour per year. For building B, using about 10 to 11 million kilowatt hour per year. For building C, using about 5 million kilowatt hour per year. For building D, are using about 10 to 11 million kilowatt hour per year, and for building E are using about 7 to 8 million kilowatt hour per year. So based on the detailed energy audit on site, we can find out the estimation of energy usage. So from the estimation of energy usage, we can know the significant energy user, or known as the SEU. Why SEU is very important? Because it can help the owner of building to tackle the sector that use a lot of energy. The largest percentage of SEU must be focused and come up with the solution to reduce energy usage. For example, for building A, the cooling equipment are using about 85% energy consumption, followed by the lighting about 19%, and other equipment are using about 16%. For building B, the cooling equipment also the majority that using of energy, which is about 73%, lighting about 6%, and other about 21%. For building C, the cooling equipment using about 87%, lighting about 7%, and other about 6%. For building D, the cooling and lighting are using almost dissimilar. The cooling use about 45%, lighting 40%, and other equipment just use about 15% from their total energy consumption. For building E, the cooling also using about 77% from the total energy consumption, lighting about 7%, and other about 20%. So the air conditioning system account about 75% of energy cost, while lighting and other equipment account about 18%, according to Rana and Kamaluddin 2012. Conducting an on-site audit is most effective approach to learn about each piece in equipment. There are three types of data collection method. One is the walkthrough assessment, second is energy survey and analysis, and lastly is detailed energy audit. Next, we go for the development of healthcare building energy index. HBI is developed that specifically for healthcare building, including hospital, clinic, and medical laboratories. Right now, we are using BEI, Building Energy Index, that used as a benchmark to measure energy efficiency in all type of building in industrial and commercial sector. But there is no unique instrument or method that determine the efficiency of energy used in healthcare facility. BEI used for all type of building, normally for the normal operation building. So why we are suggesting HBEI? Because healthcare building is differ from those other building and need their own energy efficiency standard that commercial building don't have. The criteria that healthcare building have, firstly is their operation hour that usually longer than the commercial building, and the equipment usage is normally is higher. For example, biomedical equipment using higher energy to operate. and also the work demand from the healthcare building is normally is higher than for the commercial building. So the formula to get HBEI, total energy consumption yearly, is dividing net floor area. So we can use another parameter such as number of bed or patient. Also, we can use number of laboratory tests, especially for the laboratory building. So the hypothesis for this formula, the lower the HBEI, the better the energy efficiency in the building. At the end of the day, we have to make the comparison with the current standard. Next is the comparison of total energy consumption versus HBEI index. As we can see for building A in 2018 and also 2019 used the lowest energy consumption, but the HBEI is higher, about 400 to 453. Meanwhile, for building B, they are using the highest energy consumption in both year, but the HBEI is lower, around 200. Similar with the building D, even though the and total energy consumption is higher, but the HBI is still lower, which is around 100. For building C, show the similar pattern as building A. Meanwhile, the total energy consumption is low, but the HBI is higher, around 300 kilowatt hour per year per meter square. Next. So the comparison HBI with the current standard. So the current standard used for this study is Geo Building, Diamond Building, Leo Building, and MS1525. From the graph, we can say only 2 from 5 buildings show that HBI is below the current standard. So the HBI of healthcare building must be improved while reducing the energy usage. So how to reduce or improve the HBI? We must propose the potential energy conservation measure. What is ECM? Is actually identification of possible energy saving strategies based on evaluation of site survey data and analysis of monitoring data. So ECM can be divided into three categories, which is zero cost, low cost, and high cost. For zero cost, we can see through the delamping of lighting system, which is not using any investment cost, and the owner of the building can get the immediate energy saving, which is 6,000 per year. For low cost, such as retrofitting lighting system and retrofitting street lighting, which is take about 1 year to get the energy saving. And for high cost, we can say that replacement of SCSU to energy efficient unit, or off-peak tariff rider or PTR, a scheme from TMB, and also star rated equipment and appliance, because it use a lot of investment costs. Next is the conclusion. For year 2018, B has the highest energy consumption compared to all other four healthcare building, while A has the lowest energy consumption of all five healthcare building. For 2019, the highest energy consumption was recorded in D, while A has the lowest energy consumption compared to other. And the significant energy usage in healthcare buildings show that the cooling equipment use most energy, followed by the other equipment such as biomedical equipment and office equipment. Last but not least, lighting use the least energy consumption. So the building owner must focus more to reduce energy consumption, especially for their cooling equipment in their building. So for future improvement, the data can also be collected using building management or building automation system BMS or BAS software in additional to utility bill. And secondly is the healthcare industry is very huge and comprised of numerous buildings, with a different function. So it's very important that we can split the building into the discrete portion, and we can known as it energy accounting center. From there we can go for specific department to reduce their own energy consumption. Thank you.